let's look at some basic multiplication problems. Now, I'm not interested in finding the actual answer in a number. I'm looking at just rewriting this in a much simpler form. So I'm looking at rewriting 2 times 5 plus 7 times 5 as something times 5. So I'm going to do this with a diagram to begin with. Here I've got 2 lots of 5, so I'll represent that as 2 5s over here. And I've got 7 lots of 5s. Okay, so over here I have 2 lots of 5 and 7 lots of 5, and altogether that represents 9 lots of 5. So you can think of the number in front of the times sign as telling you how many lots of this object I have. So if I have 2 lots of 5 and 7 lots of 5, then I must have 9 lots of 5 altogether, because 7 plus 2 will equal 9. Let's move on to the second one. 4 lots of 5 minus 3 lots of 5 is how many lots of 5? So again, I'm going to use a diagram, and I'll use yellow 5s to represent 4 lots, but I'll use red 5s to represent the fact that I'm now going to take away 3 lots of this. So here I have 4 of these yellow 5s and 3 of these negative 5s. Now to work out how many 5s I'll have left over, and what I'm going to do is pair one positive 5 with one negative 5. I'll do that for all of them. But I have one of these positive 5s left over who doesn't have a partner. And what's going to happen is that a positive 5 and a negative 5 are going to cancel out and become 0. Like when they meet, they annihilate each other. And these two are going to annihilate each other into nothing. And these two, when they meet, will become nothing as well, leaving me with just one positive 5 left over. So when I have 4 lots of positive 5 and then I subtract 3 lots of these 5s, a whole lot will cancel out, leaving me with just one left over. So I'll have one lot of 5s left over. Alternatively, I could have worked that out by going 4 lots minus 3 lots would leave me with one lot of 5s left over. Now for the final one. Negative 6 lots of 5 and 5 lots of 5 will be how many? Now this is a bit strange because I'm going to start with less than 0, but that's okay. We can deal with that by pulling up 6 of these negative 5s. And same thing as before, I'm going to pair up one positive with one negative, because I know that they're easy to deal with because they will annihilate each other. So as you can see, I have a pair here that will annihilate to 0, and here I've got negative 5 and positive 5 will cancel out to be 0. Here's another pair that cancels out to be 0, and another one, leaving me with just one of these red 5s left over. Now the way that we represent a negative 5 left over is that we have negative 1 lot of these 5s. Now again, we could have worked these out by going, if I have negative 6 lots of something and then I add 5 of them, negative 6 plus 5 will be negative 1. Let's change all these number 5s now and replace them with the number 2. And I'm going to see if we end up with the same number in the boxes. What I'm wondering is whether these yellow numbers have got anything to do with the answer that goes in the Okay, so there's all the 5s replaced with a 2. Let's try the first problem again and see if 2 lots of 2 and 7 lots of 2 is still the same as 9 lots of 2. So same thing, I'm going to pick up a couple of 2s. I'll get 2 lots of these for the 2 lots here and an extra 7 lots, and let's see if we still end up with 9 of them. Okay, so here are 2 lots of 2. Here are 7 lots of 2, and all together we still have 9 lots of 2. So it doesn't look like this number in yellow had anything to do with the number that went in the box. Just to be sure, let's just double check the second one. 4 lots of 2 minus 3 lots of 2, so I'll pull up some yellow 2's for the 4 lots and some red 2's for this minus 3. And now to pair them up so that I have a positive yellow 2 paired up with a red 2. And again I'm left with 1 all on its own. And remember that anything that's the opposite of each other, a negative and a positive 2, will cancel out to nothing. They'll be annihilated, leaving me with just 1 positive 2 all on its own, and again I get the same answer, 1 lot of 2. Now the same thing will happen here as well. If you have negative 6 lots of the number 2 and you add positive 5 of them on, you will still have negative 1 lot of 2. And if you don't believe me, you can draw up your own diagram. Restarting this section. So lastly, we have negative 6 lots of the number 2 and 5 lots of the number 2. So let's pull up 6 red 2's and 5 yellow 2's. So as you can see, lots of 2's paired up. A positive and a negative 2 will cancel out to 0. Negative 2 plus positive 2 is 0. These will cancel out, these will cancel out, leaving me with just 1 red 2 left over. And of course we could write that as negative 1 lot of 2. So you notice that it didn't make any difference what my yellow number was. I still got the same number in the boxes. So I wonder if that's still the same if we had a letter instead of the 2. So let's replace all the yellow 2's with the letter A. Okay, so our first example we had a 5 where all the yellow A's are, and then we had a 2, and we saw that it made no difference what the yellow number was in terms of the answers in our boxes. So maybe it might be the same for letters, so let's have a look. Let's pull up 2 A's and 7 A's. So here we've got 2 A's and 7 A's, and as we can see we have 1, 2, 3, 4, 5, 6, 7, 8, 9 A's altogether. Again, the number in the box didn't change. But notice that the name of our object, which is the letter A, also hasn't changed. Just like before when we had a 5 here and a 5 here, our answers still stay the 5. Our answer still has just an A. It doesn't become A squared. Let's have a quick look at the second one. Let's pull up 4 yellow A's and 3 red A's because we're going to subtract 3 of them. Again, let's pair off a red one with a yellow one. Now, I have here 1 positive A and I'm going to subtract an A. So if I have an A and take away an A, they will still cancel out to nothing. So all these pairs disappeared just like normal numbers, leaving me with one of these positive yellow A's. And again, we're still left with 1 lot of A's left. So again, we got the same number, and the rules for letters and numbers seem to be exactly the same. Lastly, let's pull up 6 red A's because we have negative 6 of them, and we'll add 5 yellow ones on. Okay, so I've got all my A's buddied up with someone they'll cancel out with, so I have a pair that will cancel out, cancel out, cancel out, leaving me with just one of these red A's left, which again we write as -1 lot of A's. So I just want to stress the point that the name of the object we're dealing with, here we're dealing with A's, it never changes. It's only the number that we have of them. So if we started with 2 of these things called A's and added 7 of these things called A's, we will end up with 9 of these things called A's. It doesn't become A squared as many people think.